Okay, so I'm gonna go ahead and get started. It would be nice if I had everything situated. Oh, hey, how are we doing today? Everybody have a nice evening? Relaxful evening? Okay. So I'm gonna put my finger on the corner, right? I have three geometric means. You have the outside legs and you have the height. Geometric mean means that you're going to see it twice in a proportion, right? You'll see one up and you'll see one down. See, we're getting it. Okay, so which piece of information is our geometric mean? X, 25, 36, something else? What is it? X is the geometric mean because it's the outside leg of the big triangle, which means that this triangle, if you're looking at the two, we have, this big triangle and then you have the two little triangles, right? So I it will be, if you take a look, see how you have this triangle here, right? That would be the mama bear. And then you have the big triangle, which is the papa bear, right? These two are similar. In this case, in the little triangle, the x is the hypotenuse, right? But with the big triangle, the x is one of the legs. That's why you see it twice. We did that when we were cutting out triangles and flipping them around and seeing how they match. That's why this works. So if I do x equals x down here, and remember, it is the side, to fill out the rest, it's the side it touches, because we're going to be comparing this mama bear triangle and the whole hypotenuse, because that's the hypotenuse of the big triangle. So I'm going to put, and it doesn't matter which order you place them in because we're going to be multiplying. In this case, we didn't have to do anything special because the information was directly part of one of the cases. So when I cross multiply, I get x squared is equal to 25 times 36. And the reason why I didn't just get that big number, I could, but I want to simplify when I do my square root. And when I do the square root, the square root of 25 is what? 5. So 5 comes out on the outside. And what's the square root of 36? 6. So what is 5 times 6? 30. So x is equal to 30. And normally it would be a plus minus 30 if it wasn't for it being geometry, because geometry doesn't use the negative length, because I can't have a negative length. So x is 30. Now you could have multiplied 25 and 36 out, and you would have got 900. And the square root of 900 is 30, right? It's just I like doing it this way because then I don't need the calculator. I use my brain. Okay, so now I put my finger out here. I have three geometric means. I have the two outside legs, and I have the altitude or height. Which one am I concerned with? X is the geometric mean. So I'm going to see that up and I'm going to see that down. Now, when it's on the inside, you are going to use the two pieces of the hypotenuse because you're going to be comparing the little baby bear triangle and the mama bear triangle. Where on this triangle, X is the longer leg, but in the mama bear, it's the shorter leg, right? So I need to compare these two pieces. However, I don't have this length here. How do I get this length? 4 minus 3 is equal to 1. So this length is 1. Now I can calculate this, correct? So we have x, we have x. And what am I going to place in the other spots? 3 and 1. I'm not going to put 4. I guarantee you on a test, someone would have put 4. Don't be one of those. Let's get A's on our test. So x times x is what? X squared. 1 times 3 is 3. So when I take the square root, x is just the square root of 3. And I'm just going to leave it like that. Square root of 3. Oop. Well, what's going on in the news today? um, let's look at number 3, right? Here's my finger gets put right on the corner. I have how many geometric means? I have 3. I have the outside legs, and then I have the altitude. So I'm going to be using this outside leg, correct? So you see X up, you see X down. Sometimes they're numbers, not always are they X's, right? But I have to use the piece it touches, right? Let me use a different color here. And then I have to use the whole hypotenuse because it was from the outside, but I'm not given the whole hypotenuse. How do I get the whole hypotenuse? 16 plus 65 is equal to what? 81. So I'm going to put 81 here. And what number goes here? 65. When I cross multiply, I get x squared is equal to 81 times 65. And I just left it like that because I know 81 is a perfect square. Because when I take the square root of this, what's the square root of 81? 9 can come out. But that's 65. There is no perfect square that goes into 65. Because what? How many times? What's 65 divided by 5? 13 or something like that. Yes. So 13 is a prime number. 5 is a prime number. Right. So this is just going to be 9 square root 65. There are no perfect squares that can divide equally into that. Okay, now we're switching, right? We are not doing geometric mean. This one is what? This is special triangles, right? And with the special triangles, we have 2 different patterns. If this is 30 and this is 90, what's this angle have to be right here? 60, because it all has to add up to 180. So this is a 30, 60, 90. What's the pattern for 30, 60, 90? A, A square root 3, 2A. I had a student this morning that put 2A for the 90 for the 45-degree angle. And then he ended up getting them wrong, right? So we have to be careful on writing our patterns correctly. And you are allowed to use your notes. I am not evil. I know that it's only 8 weeks long, so it's hard to get all these memorized. So, what am I given? I'm given across from the 6, or the 30, right? Whenever you are given across from the smallest side, we can just end up substituting. You don't need to solve for anything. Here I know A already. What is A? 6. See how I have an A here and I have an A here? You just substitute 6 in. So this would be 6 square root 3. And this would be 2 times 6, which is 12. So this one just followed the pattern directly. Most of the ones on your quiz will be following it directly. I will have maybe one or two that you'll have weird square roots, okay? But I needed to do that for those who are going to college, and it is part of our standards. So, okay, so here, if this is 30 and this is 90, what's this over here again? 60. This time I'm given across from the 60. 60 is not the smallest angle. So I'm going to have to solve for A, right? This one I have to solve for A. This one becomes a little bit more complicated. This one was easier. That one was easier, right? This one is easy? No. Okay. So I need to solve for A. I know that 30, 60, 90 is A square root 3 to A. I'm given across from the 60, so A square root 3 equals what? 3. I need to divide by the square root of 3 to be able to solve it for A. Can I leave this as 3 over square root 3? No, I have to do what's called rationalizing the denominator. So, what do I have to do? I have to multiply by square root of 3 over square root of 3. This becomes 3 square root 3. And then underneath here, this is just 3. What happens with these outside 3's? Yeah, what's 3 over 3? 1. This just reduces to a 1 or just square root 3 because 1 times square root 3 is square root 3. So across from A, across from the 30, this side here is square root 3. Now that I have A, because that was the first step, I had to solve to get A. The second step, now I could just substitute to find the missing. Once I know A, substitute. So which one am I looking for? I'm looking for the 90, right? And I know 90 is 2 times A. And what's A? Square root 3. So 2 times square root 3 is just 2 square root 3. So over here, this would be 2 square root 3. How are we doing on those? Better now that we had that extra day of practice? Okay. So over here, this is 60. This is 90. What's this over here? 30. I am given across from what? 90. So is this a happy face or a sad face? Sad face. And it's a sad face. And I'm silly like that for a reason. It's to try to help you remember when you have to solve versus when you can just substitute in. And hopefully being silly helps you remember that. Okay. Oh, that should have been a 90. So a square root 3 to A. I have to solve for A first, right? So we're given a cross from the 90, so 2a equals 6 square root 3. What do I do to both sides then? Divide by 2, and a is equal to 3 square root 3. So now I know across from the 30 is 3 square root 3. Everybody agree with that? Did I go too fast? Okay, now I need to do number 2. I'm going to substitute to find the other missing one. And so what am I missing? I'm missing across from the 60. So if 60 is a square root 3, a is 3 square root 3, I'm going to do 3 square root 3 times square root 3. What is square root 3 times square root 3? Yeah, this becomes 3, and the outside is 3. What's 3 times 3? 9. So across from the 60 is 9. Right? Okay. 45. What's this over here? 45, right? And then this will be across from the 90. So 45, 45, 90 is what? What's the pattern? That could be like a song. Oh, oh, okay. Not an exciting song. Am I going to have to solve for A first, or can I just directly substitute in? What am I given? Where am I given across from? 90. Is 90 your smallest angle? No. So I have to solve first, right? I have an extra step. I have to solve for A. So if a square root 2 equals 8 square root 2, well, this one's not too bad to solve for, is it? Because I'm going to divide by square root 2. But when I divide by square root 2, these just cancel, right? Nothing really weird. A is just 8. And so since it's a 45, these two have to be the same. Both of these are 8. Right? Okay. One more, and then we learned trigonometry today. Yay, it's one of my favorite lessons. My students tend to really like trig. It sounds like it's going to be super hard because it says trigonometry, but most students are like, oh, this is easy. At least the way I explain it, it makes it easy. Okay, so this is 45. What's this over here? 45. And again, this is a 45, 40, 45, 90, which we said was a square root 2. And I'm given across from where? Across from the 90. Is that the smallest angle? No. So what do I have to do? I have an extra step. I'm going to have to solve. I can't just substitute. So a square root 2 equals 4, right? I divide by square root 2. So a is equal to 4 divided by square root 2. Can I leave it like this? No. I have to rationalize the denominator, which this then becomes 4 square root 2 over 2. When I take 4 and divide it by 2, what do I get? 2 square root 2. Because 4 divided by 2 is 2. So both of these would be the same. That'd be 2 square root 2. Okay, I'm going to pause the video. We are going to use trigonometry. Now, How many people have ever saw out in the road somebody with a big tripod wearing the yellow vest and they're looking through this tripod and they're maybe taking pictures? Have you ever seen that? Are you sure? I see it all the time. No, those people are called surveyors. Surveyors use trigonometry all the time. Now, though, and it's a pretty cool. I like if I wasn't a math teacher, I would look into that because now instead of like risking their lives and being out in the middle of the road with their tripod, guess what they're using? They're using what did you say? Not phones, drones. They're using drones now to do a lot of the measurements for them. But basically, they're trying to find, they make right triangles and they're just trying to find out like gradients or lengths of different things. People who are surveyors are used for a lot of engineering firms or the city, right? So if they were like we were at Meadows and they were putting in the new purple line, so that whole road was all tore up, right? And they had surveyors out there all the time because they were putting in new roads and they had to make sure things went in. So my son works for a company that does wastewater management and he does their CAD drawing, which if you've ever saw blueprints of something, that's what CAD drawers do. And he's like underground of all of Indianapolis. So if you, I went because he gets to work 2 days out of the house, so I snuck in his room because I'm a math teacher and I'm a mom. And so he was working, and I was just peeking on what he was working on. It was pretty cool. I got to see all that. But he was able to do surveying too. I kept saying, well, you should ask to be trained because who wouldn't want to work with drones as part of their jobs, right? So there are real life applications to this. If it is nice out next week, let's all pray that it's nice out. We will go outside and we will use trigonometry to find like heights of the flagpoles or trees or the building, and it'll get us out of this classroom. Okay? You'll never change your life until you change something you do daily. The secret of your success is found in your daily routine. Do you all agree with that? Yeah. Who here reviews their notes daily? You do? And I bet you get good grades because those who review their notes daily tend to do well in classes. Those are our goals. So today we are going to work on, we're going to make fractions because ratios are fractions. We're going to use sine, cosine, and tangent to find missing side lengths and missing angles. Take a minute right now to look at your calculator. I'm going to pull mine up. But when I pull mine up, I have to be careful. I have to change the mode on mine. You don't have to. I just do. Just because. And if I forget to change the mode, I'll get the wrong answers and you'll all look at me funny. Okay. So, does everybody see sine, cosine, tangent? Everybody see it? Okay. Now, this is very serious. We do not call sine sin because we do not sin in math class. We're good in math class, right? Okay. It's sine. I just giggle at you if you say sin because I always like saying we don't sin in math class, right? Okay. So trigonometry is actually a whole branch of mathematics. When I was in college, I took a course that the whole semester was trigonometry. And we learned trigonometry identities and all this fun stuff. Sine squared plus cosine squared equals 1, all that fun stuff if you've been to calculus. And that sounds familiar to Keylon, I read, right? Yeah. That's the only one I would always remember is sine squared plus cosine squared equals 1 because then I could derive all the other ones. But anyway, we're only going to do one piece of trigonometry. Um, But if you go into a STEM field, science, technology, engineering, mathematics, you will probably take a trigonometry course, or they may call it pre-calculus. You ever take pre-calculus, it's basically a trig class. Okay, so remember that two sides of a right triangle form a right angle called the legs. Everybody agree with that? Okay, the third side, opposite the right angle, is called the hypotenuse. There are three basic trigonometry ratios. They're called sine, because we don't sin in math class, cosine, and tangent. Okay? Now, there is a mnemonic aid that people use to remember this. This is the ratio. Is it in your notes, or do you have to write it? Oh, I think I gave you. Oh, you got to write the ratios below. So I want you to write sine. All what that little circle with the line through it, that's just called theta. It's a Greek letter, and mathematicians tend to use theta when talking about an angle measure. You could use x if you want to. I'll probably use theta because I was in math a lot, right? So I don't want you to be confused on that. But sine is always going to be the opposite of the angle you're talking about over hypotenuse. Cosine is going to be adjacent over hypotenuse. And tangent is going to be opposite over adjacent. And I'll wait until you're done writing this down. Everybody get a chance to write it down? Or I still see people writing, so I'll wait. I'm I'm drinking coffee and tea. No, it's weird. This has caffeine, this one doesn't. So when I need the boost of caffeine to wake me up, yeah. Okay. Can I move now? Okay. So a way to remember it is SOHCAHTOA. Can everybody say that? SOHCAHTOA. We'll say that one more time. SOHCAHTOA. So is just the first letter of each of these. So it's sine equals opposite over hypotenuse. See how you have the SOH? So SOH. Ka, cosine, adjacent, hypotenuse. Tangent, opposite over adjacent. Now, I'm going to pause this video because I don't want it recorded what I'm about to say. Oh, Pete. No, 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 no. Oh, no, that's not what I wanted to do. Okay. My daughter, because, I helped her out with all her classes, would whisper that into all the students. And then they'd all giggle, and then the teacher would be like, "What are you giggling about?" Okay. Yeah. Okay. Now, trigonometry is based upon the angle that you are referencing. If you reference the wrong angle, you are going to get the wrong ratios. So see here how it says sine x. Everybody either use your pencil, use your finger, use something, but point to x because it's from x that we start labeling. And if you accidentally choose the wrong side, you're going to get everything incorrect. So see here, my finger's on x, right? Okay, so what side is opposite of x? The 3, right? This is called opposite. Now, which one is the hypotenuse? The hypotenuse doesn't change. It's the opposite and the adjacent that could change if you're referencing the incorrect angle. Okay, adjacent is the side that helps make the angle you are referencing, but is not the hypotenuse. So I always label opposite first and hypotenuse second because the leftover one will always be adjacent, right? Adjacent means that it helps make this angle of x, but it is not the hypotenuse. So if I want the sine of x now, what two sides am I going to use? It says opposite. What number was opposite? And what number is hypotenuse? 5. Can I reduce this fraction or is it already reduced? It's already reduced. You can't do anything. This is the answer. Because it was just asking for a ratio. We're not trying to find a missing side length. We're not trying to find an angle. See here how the instructions said ratio? Ratio means fraction. Right? Okay, so now I'm going to go to question 2. Now it wants cosine. And which letter am I talking about? Which angle? X. My finger has to go on X here. And now I label it from X, right? So what side is opposite X? What side is my hypotenuse? And then what side would be the adjacent? 9. Now that I have everything written out, adjacent is what? 9. And hypotenuse is 41. Am I going to use the 40? No. Cosine x is equal to 9 over 41. Again, I can't reduce this fraction, but if I could, I should always reduce my fractions. 41 is what we call a prime number. Do you know that all your security codes and internet on this security on the internet is all based on prime numbers, by the way? So now this one. What letter am I talking about? Z. Put my finger on Z. I'm going to label. What's this one? Opposite of Z. What's the hypotenuse? 29. And then what would I label as adjacent? So tangent of z is going to equal opposite, which is 20, over adjacent, which is 21. Can I reduce that fraction? No. Labelers tend to be winners, non-labelers tend to get things wrong. So everybody, do number 4, number 5, and number 6 for me. And I'm going to walk around and check your work. More books to bring in slowly but surely. Okay, so I walked around. Do you see how important it is to label your triangle first? Yes, labelers are winner. I used to, you know, the old Dr. Pepper commercial? I'm a pepper, you're a pepper. Wouldn't you want to be a pepper too? I'm a labeler, you're a labeler. Wouldn't you want to be a labeler too? Okay. Yes, this highlighting does help. Okay, so this is how we use it. Now, in your calculator are stored values for each angle ratio. Okay? There were mathematicians years and years and years and years and years and years ago that set up these tables and figured out all these ratios based upon right triangles. Now, we are lucky because now these calculators can hold these tables. So when I say sine of 24 degrees, that's an actual number stored in your calculator. Now, when I first started teaching, because I'm old, not all people had scientific calculators. They were very expensive at the time. I had to print out the tables, keep them on the tables. They were actual things you look up, and put those papers on people's tables or hand them out, and they actually had to look them up instead of use a calculator and then use the calculator for the math. So you are blessed because you are in a new age of technology that it is stored in your calculator. So sine of 24. So I have this, right? And the example says, find the missing side, and it wants x. I know that if I label from here, right, what's x considered when I'm labeling? What side is it? This is opposite. What is the hypotenuse? And then what is adjacent is here, but I'm really don't care because there's no number, there's no letter. Here's opposite, here's hypotenuse. That's how I knew I would use sine. I would look up my sine equals opposite over hypotenuse, right? Cosine is equal to adjacent over hypotenuse. Tangent is equal to what? Opposite over adjacent. Or I could think of so, ka, to, or some old hippie cut another hippie doing bad things. Right? Okay. So you wouldn't be given the sine stuff over here, right? You would just be given the triangle. You would have to say, oh, I'm looking for x. I have this hypotenuse. Then you would look over here and say, well, which trig function is opposite in hypotenuse? And then you would say sine, because I don't sin in math class. And you would put sine and then the angle you were referencing. So this 24 is the degree. I know it equals this fraction, opposite x over hypotenuse 283. Then all I'm doing is cross multiplying. I'm going to put this over 1, right? When I cross multiply, x is equal to 283 times sine of 24 degrees. Usually you put the number first, then the trig function. The only reason you do that is that when you're using your calculator, if you forget to close the parenthesis, you'll have a problem if you put the trig function first. If you always close the parentheses, it doesn't matter which order, but it does if you forget to close your parentheses. So everybody right now, make sure you can do this on your calculator. And I have to actually change my mode. Your mode should be fine. This is just because it's a scientific calc. Oh, no, it saved it. Okay. So 283. Then you go find your sign button. Everybody have a sign button? And then put 24 and then press enter. And you get what? 115, and it's rounded to 0.1. Okay. So this is typical on a test or your worksheet, right? I'm going to put my finger on the 29 degrees. I'm going to label. So here's 29 degrees. This side is what? Opposite. This side is hypotenuse. And then the leftover one is adjacent. Now, you have a number for adjacent, so circle that. You are looking for hypotenuse, circle that. Now, go back in your notes. Which trig function uses adjacent and hypotenuse? Does everybody see its cosine? Cosine is equal to adjacent over hypotenuse. So cosine of 29 degrees is equal to, what's the adjacent? 20, and then x is over here. So I'm going to place this over 1, and I'm going to cross multiply. X times cosine 29 is equal to 20. How am I going to solve for x? What do you do to isolate it? This is just a number, remember? What's the inverse to multiplication? You're just dividing. So divide by cosine 29, because remember, this is just a number. So x is equal to what? What is 20 divided by cosine 29? 20 divided by cosine 29. Which, what would I round that to? 22 point, is it going to be 8 or 9? 9. So right here has the 8. Behind it is a 6. 6 is bigger than 5 because it's 5, 6, 7, 8, or 9. This gets bumped up. So this should be 22.9. And it's a length. They didn't give us the length. So I'm going to put a U for units. You don't have to, but I'm a math teacher and I should have done that earlier, but I didn't. Okay, any questions? U just stands for unit. Yeah. You don't have to put a U if you don't want to. It's just, it didn't tell me if it was in feet or inches or centimeters. When you do your project outside, you're going to have to tell me what unit you were in. Okay, so now I'm at SOHCAHTOA again. Where do I put my finger? At the 70. My pencil or my finger should be at the 70 right now. And I'm going to label. Go this way. What's X? Opposite. And then here's hypotenuse, right? And then what am I going to label the 16 as? Adjacent. So I have adjacent. What am I looking for? Opposite. Yes, you are correct. It'd be tangent. Because tangent uses opposite and adjacent. Am I using hypotenuse? No. So then I go tangent 70 is equal to, what is it? Opposite over adjacent. So x over 16. I place this over 1 and I'm going to cross multiply. So I get x is equal to 16 times tangent 70. So what does x equal? Approximately, because we'll probably be rounding. Did everybody else get 43.9? It's rounded correctly, okay. And remember, this isn't a degree, this is the side length. It's whatever, it's this side length is 43.9. So was I wrong? Is this a little bit easier than what we've been working with? Just a little easier, maybe? Okay, now, when looking for a degree, we need to use the second key because we're doing an inverse. Is that on there? It's not on there? Yep. Okay, so when you are looking for the degree, you have to use what's called the inverse key. You're still going to put your finger here, and you still label your triangle. What's 33 going to be? Opposite. What's 58 going to be? Hypotenuse. And this is adjacent. So what trig function would we use? I have opposite. I have hypotenuse. Sine. So sine of theta, or you could put an x, has to equal 33 over 58. You are going to use the second key and hit sine. When you do that, it should look like this. Does it look like that on your calculator? Do that now. Go second, sine. Everybody do that? Second sine on their calculator. Now, when you put this in your calculator, you're going to do 33, hit your division key, hit your division, which should come up as like a slash, 58. And then press enter, and that will give you what the degree is. 24, is it 24.6 or 7? Oh, so it's 24 point, oh, 34. I got bad ears. Ah, 34.67, which rounds to what? 7. So that should be a 7. Oh, 7. And this is a degree. So put a little circle because that's a degree. So it should be 34.7 degrees. You understand? Okay, everybody try and do number 10. And I will walk around and check to see if you get the right answer. And I'm going to pause this. Yes. Oops. So for this one, it was tangent theta equaled 57 over 24 because this is opposite. No, this is opposite is here. Hypotenuse is here. Adjacent. So you know you're using tangent because it's the trig function that uses the opposite and adjacent. You have to use your inverse, your second key, because you're looking for the degree. To get that, you would do second tangent, and then 57 divided by 24, and this should have been 67.2 degrees when rounded. Okay, the next one, when you do this one, we got 30, what was it, 30 points? 30.6. And the reason is, here's the degree, opposite, hypotenuse, adjacent. So you have to use tangent again. Tangent theta is equal to 26 over 44. So you use your second key to get the inverse. So tangent's inverse 26 divided by 44, and that will get you 30.6. Now, this one's not on there, I don't think. So here, you do have this one, right? This is what we are going to do when we go outside, except we're not going to do the Washington Monument. A math student is standing 25 feet from the base of the Washington Monument. The angle of elevation, that means her looking up from her horizontal line of sight, is 87.4 degrees. We will make, with a protractor and a weight, how to calculate angle of elevation when we go outside, okay? And that's why we'll need to do this in groups. She's 5 feet, or her eye height is 5 feet tall. Meaning, if I'm using some device to measure angle, I'm only measuring it from my eye up. So I have to add my eye height, which is 5 feet. My eye height is a lot less because I'm under 5 feet tall. So you will first then, if this is my angle right here, right? Put my finger there. What's this? This is opposite. So the height of the Washington Monument is opposite. The hypotenuse is this right here, which I don't have any information on. This is what I'm looking for. And then over here, I'm 25 feet away from the base, which this is adjacent. So if I have adjacent, I'm looking for opposite. Which trig function am I going to use? What's opposite and adjacent? Tangent. So tangent of 87.4 degrees has to equal opposite, which is x, over 25. So I'm going to, actually 25 feet. I'm going to place this over 1 and cross multiply. I get x is equal to 25 feet times tangent 87.4. Do that on your calculator right now. And what do you get? 25 times tangent 87.4. Well, I hope so, because I think the Washington Monument is pretty big. So 25 times tangent 87.4. Okay, but that's just from her eye height. So that would be 550 point what? Point 5. But I have to add her eye height because that's just from her eye up. So you have to add that 5 feet also. So the correct answer then would be 555.5 feet. Does that make sense or doesn't make sense? Okay, so go ahead and go on your break. When you come back, I have 2 worksheets. One is just practicing, and then one is word problems. I will take one of the word problems from the worksheet and place those on the test. Okay? So and I give you the answer key also. So make sure you know how to do the word problems because you will see those on the test. Any questions on that?